Good day, learners! Welcome to Edwarriors Vlog Tutorials. For today's episode, we will talk about factoring polynomials by greatest common monomial factor. Our objectives today: number 1, we have define factoring. Number 2, identify the common factor of a polynomial. And number 3, factor polynomials whose terms have a common monomial factor. In your grade 7, you learned how to multiply polynomials and find special products. Your knowledge of special products will be very useful in factoring polynomials. Are you ready to learn? What are the possible dimensions of a rectangle whose area is 8? Again, what are the possible dimensions of a rectangle whose area is 8? It could be a 1 by 8 rectangle whose length is 8 and whose width is 1. Or it could be a 2 by 4 rectangle whose length is 4 and whose width is 2. A rectangle whose area is 8 is either an 8 by 1 or 1 by 8 rectangle, or a 4 by 2 or 2 by 4 rectangle. Notice that 1, 2, 4, and 8 are the factors of 8, meaning these are the numbers that can divide 8 evenly. To check our answers, let's go back to multiplication. 1 times 8 is equal to 8. Also, 8 times 1 is equal to 8. Now, 2 times 4 is equal to 8. And 4 times 2 is also equal to 8. Meaning 1, 2, 4, and 8 really are the factors of 8. Before we come up with the definition of factoring polynomials, let us compare first the two processes. First, we have the multiplication, and the second is factoring. We all know that multiplication, we deal with the factors and we come up with a product. That is, for example, we have 2 times 4. 2 and 4 are the factors, and we come up with 8, which is the product. And to factoring, we dealt with the product and we come up with the factors. Example, we have 8, which is equal to 2 times 4, or 4 times 2, or 1 times 8, or 8 times 1, as presented a while ago. So, to factor a number means to write it as a product of 2 or more numbers. Or by definition, factoring is the reverse process of multiplication. Is everything clear about factoring? Now let's apply the concept using variables. What about a rectangle whose area is x squared minus 2x? What are the dimensions of the rectangle? Using the algebra tiles, we have here x squared, negative x squared, x, negative x, 1, and negative 1. But remember, x squared minus 2x cannot be illustrated this way. This is not correct. Instead, we have x squared minus x minus x. To get the factors, we have to use here the positive x. We also have here the positive x, then the negative 1, and the negative 1. The length of our rectangle x squared minus 2x is x minus 2. And the width of our rectangle x squared minus 2x is equal to x. Therefore, we have the factors x minus 2 times x. Therefore, x squared minus 2x is equal to x times x minus 2. To check our answer, we will use the multiplication process. So we have here x times x minus 2. Using the distributive property of multiplication, we multiply x times x, which is x squared, and negative 2 times x, which is negative 2x. If you have observed that x squared minus 2x was our given, therefore, we got the correct answer. Now, what have you observed with the product and the factors? X squared minus 2x equals x times x minus 2. Have you observed that x is common to both terms? Yes, correct. How about x minus 2 as the result when we divide the given polynomial by its common factor? You're right. Now I would like to give you the steps on how to factor out polynomials by greatest common monomial factor. Step 1. Determine the number of terms. Step 2. Determine the greatest common monomial factor of the numerical coefficient. Third, determine the greatest common monomial factor of the literal coefficient. Multiply the two greatest common monomial factors. Next, divide the given polynomial by its greatest common monomial factors. And lastly, write the factored form. Now let's examine the examples in your module. Example number 1, we have 6x plus 3x squared. Step 1 is to determine the terms. So we have 6x and 3x squared. Second step is to identify or determine the greatest common factor of the numerical coefficient. And since our numerical coefficient is 6 and 3, and let us have to find a number that can divide 6 and 3 evenly. And that number is 3. Because 6 divided by 3 is 2, and 3 divided by 3 is 1. So, 3 is our greatest common factor of the numerical coefficient. Third step, find the greatest common factor of the literal coefficient. So our literal coefficients are x and x squared. And let us have to think of a variable that can divide both x and x squared, and that is x. Because x divided by x is 1, and x squared divided by x is x. So our greatest common factor of the literal coefficient is x. Third step, multiply the greatest common factors of the numerical coefficient and the literal coefficient. So we have 3 times x, and that would result to 3x. Next, divide the given polynomial by its greatest common monomial factor. Since our polynomial is 6x plus 3x squared, so let us divide each term by the greatest common monomial factor, which is the 3x. So, let's do it one by one. 6x divided by 3x, and the answer is 2. How to check? 2 times 3x equals 6x. Next, we have 3x squared divided by 3x, and the answer is x. To check, x times 3x equals 3x squared. So meaning we have here 2 plus x. And the last step is to write the result in a factored form. Remember that this is the first factor and this is now the second factor. So the factors of 6x plus 3x squared are 3x and 2 times x. Let's have another example. 12x cubed y to the power of 5 minus 20x to the power of 5 y squared z. Let's go back with the first step. Determine the terms. So we have here 12x cubed y to the power of 5, 20x to the power of 5 y squared z, and these are our terms. Next, find the greatest common factor of the numerical coefficient. Since our numerical coefficients are 12 and 20, and let us think of a number that can divide 12 and 20 evenly, and that is 4, because 12 divided by 4 is 3, and 20 divided by 4 is 5. Therefore, 4 is the greatest common factor of the numerical coefficient. Now, let's find the greatest common monomial factor of the literal coefficient. Since our literal coefficients are x cubed y to the power of 5 and x to the power of 5 y squared z, let's examine one by one. So, for x cubed and x to the power of 5, our common factor is x cubed. And for y to the power of 5 and y squared, our common is y squared. But for z, there's no common factor. Next, we have to multiply the greatest common factor of the numerical coefficient and the greatest common factor of the literal coefficient. So we have here 4x cubed y squared. Why? Because 4 times x cubed is 4x cubed, and copy y squared. Or 4 times x cubed y squared is equal to 4x cubed y squared. Simple as that. Now let's divide the given polynomial by 4x cubed y squared. So we have 12x cubed y to the power of 5 divided by 4x cubed y squared minus 20x to the power of 5 y squared z divided by 4x cubed y squared. So let's divide individually. 12 divided by 4 is 3. X cubed divided by x cubed is 1. But 1 times 3 is 3. Y to the power of 5 divided by y squared is y cubed. Minus 20 divided by 4 is 5. X to the power of 5 divided by x cubed is x squared. Y squared divided by y squared is 1. But 1 times 5x squared is 5x squared. Then copy z. Remember that this is the second factor and this is the first factor. So the factored form of 12x cubed y to the power of 5 minus 20x to the power of 5 y squared z is 4x cubed y squared times 3y cubed minus 5x squared z. To check your answer, always perform the FOIL method or the distributive property of multiplication. And that ends our session today. Hope you have learned a lot in our discussion. Thank you for watching. Bye-bye.
Edward Marie. Hi, Edward Marie. Yay!